So far, we have created the complete schedule. Now, the case study number 4, schedule development. We know the background of this project. The WBS is authorized almost. Control accounts are already established. And a budget for each control account is determined. Now it is time to develop the project schedule. The project planner's scheduler, Mr. Riaz Simon, has tasked to develop the schedule. Planner scheduler has developed the schedule with some inputs from control account manager. A copy is attached. Now, your assignment. The planner scheduler claims that the schedule is already to be baseline. Evaluate the project schedule and determine whether the schedule is ready to be baseline. Discuss what needs to be done to improve the schedule that supports the EVM.
This total float column, the total float numbers, the total float durations are given. Now we see why there are so many activities here with more total float. For example, if it is for the valve data sheet, it says around 289 days approximately. This is a huge float. Here, what does it mean? It means that an activity can float for 280 days, meaning that it can either extended or delayed by 289 days without having any impact on project completion date. Now, this scenario, we do ask one question. It is the right assumption as far as this project schedule is concerned. So we need to have more information. We need to ask that question for getting more information about the float. Probably, when you see a large float in the schedule, you have to have a question and what are the assumptions they have made, whether this float is really meaningful or not. And if not, the first thing you need to check whether activities are logically and properly linked with the other activities, the parallel successor logics. As far as right build-up schedule is concerned, the activity must be properly linked with. It is like the network activities that are logically linked together. Now, the moment you are seeing the large flow for an activity, something has to be born in your mind. That is some logic or some of the predecessor. Something is missing in the schedule. That type of thought process has to start in your mind. So it is better to go first and check whether or not the activity logics attached and the activities are right linked. And of course, you have to have a question whether or not the float is reasonable or unreasonable. But most of the time, for such a large float that you have see, it is an indication of a missing logic or vice versa. Maybe we can call it as open-ended activities, unclosed activities, or dangling activities. It means there is some predecessor logic is missing. That is why causing the large flow. If you are connecting in such a way, maybe this can be closed. And as you've seen, there are many activities have a huge, large floats. So here, there are so many activities, 200 days, from a lot of activities going beyond 200 days. By all means, while checking this program, it is very clearly understood this schedule is not ready for the baseline. And therefore, a lot of corrective action required to establish and bring back to the baseline fixation. Experiences delay because it is not properly linked with others. These delays won't immediately affect other activities or the project's completion date as indeed. Consequently, it is clear that the schedule is not finalized yet. There is a need to revisit and ensure all connections, the relationship logics are established correctly or not. Small experience with a personal project experience of my own. In the similar one of the engineering project, our management insisted that no, there is no task should have longer than a month, which was quite challenging for an engineering project. It is very difficult because so many engineering activities are involved, especially in the EPC, oil and gas type of EPC. So many engineering activities involved in the greenfield projects. When we approached the control account manager for the task durations, the estimated task duration, then he often estimated around 60 days. This posed a problem as nothing could exceeded maximum 25 to 30 days. So we had to have meticulously break down task to ensure none exceeded more than 25 days and with its limitations. While this initial effort felt laborious, it paid off. Our schedule became powerful tool. Any delay, such as waiting for client directions or document reviews, become clearly visible. Along with its cascading effects on subsequent activities, this was all thanks to the rule of keeping activity durations within the reasonable time frame, which in which accordingly the PMI guidelines should not exceed more than 2 times the reporting cycle. In principle, the durations are between 8 hours to 80 hours normally. That's what the PMI recommendations. This the other rule, what practical usage is, it should not exceed more than 2 times the reporting cycle. For example, if my reporting cycle is on a weekly basis, means so my maximum duration should not go beyond 14 days. I mean, the cycle of the week. Maybe we are working 5 days a week or 6 days. Okay, it is irrelevant to the nature of fixing the duration. Maybe you can say if it is a week means the 2 weeks. This rule makes sense because it takes a stretch beyond this limit. It becomes a challenging to track the manage their progress very effectively. It underscores the importance of breaking large tasks into smaller, manageable components. Environment is horizontal and vertical traceability. If you see here, this especially for the process mechanical engineering part, now the ISO and the MTO piping starts by 20th May and it finishes by 16th June. Basically, this is directly linked with either functional description or with valve data sheets. Now, because it could have been started earlier, but it is delayed by more than a month, I mean, 4 weeks, which is supposed to be finished by, for example, the functional design is 11th May, and I'm almost, we are waiting 10 days to start the piping. So this is what the vertical traceability. Whereas if you refer the next document, for example, this structural engineering also you see the structural design DCS start by 20 April to 12th March. Then of course the next activity immediately starts. But whereas if you compare to the detailed fabrication drawings, this is getting delay. But maybe some reasons for the procurement also involved here. But anyway, this is a very huge duration. I mean, there's a delay in the vertical traceability. Now is supposed to start by 28th or 27th or 28th May, but we're delaying for about 25 days, which also affecting the schedule. However, this is not included in the, not coming under the critical path, but even though vertical and horizontal traceability and how it is properly linked needs to be completely validated and verified. Coming back to this E&I part, this is very simple. Now the total process in the data sheet starts from 28th April without any break. It continues and it goes to IO scheduled to completed by 13th July 2021. Here there is no issue. So similarly, we have to check each and every piece of the schedule. What the schedule has been prepared for baseline it. We have to completely thoroughly check it. Now the next question, what else do you think about WBS? Whether it is aligned properly or developed in right way? WBS that we have developed in more detail. Of course, what we are seeing here in the schedule. In there, we have disciplines and a lot of things we have to align with it. Here is a more simple. We can see the disciplines and don't think the pack. Completed the detailing what we are showing here in the WBS. Under the WBS, this is very clear. We should not miss any even single activity, so that if you miss something, then later it will be very difficult to add or connect accordingly. So better you have to list properly, and we have give the more detail in the activity listing. While developing the WBS, consider is aligning your schedule with the work breakdown structure, WBS. This alignment provides incredibly valuable when it comes to integrating your schedule, scope, and cost. Even without a fully integrated system, you can establish this connection manually by ensuring that everything is structured according to your WBS. For instance, suppose your schedule is structured in line with your WBS and your cost is also tied up to the same WBS framework. In that case, validating progress becomes straightforward. You can simply incorporate the WBS in your cost system with only in your scheduling system. This is just integrating with financial CBS into WBS. If they match, it becomes easy to access the alignment between your cost and the schedule. And of course, this can be used for the right progress measurement. Very regrettably, many project professionals often overlook this alignment. They are missing this, to be honest, leading to the lack of synchronization between cost and schedule. Consequently, they often struggle to derive meaningful insights from the earned value analysis, because when it is this is one of it is a fundamental requirement is establishing a strong connection between cost and the schedule. Without this integration, the reliability of your data comes into question. So we cannot give any promises that your end value is going to give the right answer or right the status of the project. A end value analysis is an immensely powerful tool, provided that you have laid down the foundation for seamless integration. Without this crucial aspect in place, it is unrealistic to expand the end value to work wonders. Correct? As a manager, you might find it very beneficial to request your planner or scheduler to provide your what you are looking in the log, keeping all the printouts in hand, as it can offer further insights in the project's workflow, duration, and other essential aspects. However, in case of issuing your schedule report, it is strongly recommended to run a log and view the schedule log and have it printed out and along with your schedule. And this snapshot is out of a Primera, where you can hit run schedule, you can see view log, and you can have the copied, saved it in a place where you click on view log, this what you will see. Now how we are going to see the schedule log, the schedule report. Just to go and check where it is in the correct data date. and ensure that it is log file or not, and then go and see the view log, you will get the report. Once you are defining for the scheduled report, and then another window we are seeing here, what we are getting in the note. For example, here there are so many information about the scheduling settings, and there are about the project, there are so many information. But here very few of the statistics we can see. Now, for example, our project activities are listed under 211 numbers, and whereas because this is still, it is not baseline, there is no completion and all. So now here you see the relationship is 329. It means the relationship should be always more than the activities what you have listed. And it is very strongly recommended to get this type of small piece of information. And you see here, the warning shows there are activities without successors. There are so many activities are listed, which is don't have any successor. But we have to check whether it is really mandatory requirements, or sometime no. This will be that some of the activities like finishing activities cannot be connected to the subject to the appropriate other successor activities. So we have to be very careful to check that. And coming here, that what we are seeing is the critical activities. How many critical activities are there in the project? We can see. And moreover, the time to time period when we are updating the critical activities, this also, we'll started doing the updating I'm talking about. So this all the critical activities all keep on increasing or decreasing. This also we have to closely monitor while updating the program on the project schedule. After so many discussion, Benny, our senior project control, came with a solution, and he has fixed all the required changes, and it has been modified for the revised baseline. Now our baseline is ready for further move.
Now you can see the schedule here. That is what the case study number 4. We have taken the project from Primavera. Now in this Primavera schedule, you can see activity ID, activity name, and the original duration, then start and finish, and then total float. Now, to be the honest, this schedule is completely developed now. Almost it is ready for baseline now. But even though for understanding purpose, we want to do some of the cross-checking how the schedule has been developed and whether this is ready for the baseline, to fixing the baseline. Now you see here in the total float column, and one more thing, as far as this project is concerned, it is completely a critical concept. Most of the activities are very critical since the original duration has been planned with 313 days. Now, therefore, if you see in the bar area, complete bar chart shows with the red color, which is most of them are critical, except a few. Where here see the mechanical electrical is a plumbing, welding, electrical. This is only the non-critical. And moreover, even though we have completely checked the relationship also, it is all almost a relationship is made. Now you see here the total float, only the except the mechanical and electrical, especially the plumbing, welding, and electrical works are non-critical. Independently, this is running now. Not only independently, it has been directly linked, and therefore the float shows 20 here. Rest of the activity correctly we have developed, and so many links already we have closed. This is how we are going to make the schedule development. And apart